Kia ora, Year 9. This is a short video going over some angle problems where we have to find the missing angles. So in this video I'm going to look at these 6 questions, but I just want to say a little bit about where they came from. So they're from one of my very favourite maths teachers, a man called Steward, and you'll recognise these because I use them quite often in class. So very sadly he died while we were off school for lockdown, and the outpouring of people saying how much they loved his maths tasks was just amazing. And last year he said that he didn't mind if I did YouTubes of them, so I'm going to keep on doing that. So these are just 6 questions from him, and they practice a lot of our basic skills with parallel lines and angle reasons. So I'm going to do one per screen. What I want you to do now is to pause the video and have a go at a question and then watch me go through it. Okay, so this will take about 10 minutes of video time, but longer because you need to be going through the questions. So let's look at the first one. So this is an isosceles triangle and we have to find angle A. What do we know about isosceles triangles? Well, there are 2 things that are going to help us. We know that angles in a triangle have to add up to 180. And we know that the base angles in an isosceles triangle are the same. So here's how I would set this up. I'd start off by saying that the leftover bit is 160 degrees. And we know that because angles in a triangle equal 180. Now we've got A here, but we've also got A here. So 2A is equal to 160 degrees. A must be half of that, so A is 80 degrees because base angles in an isos triangle are equal. Okay, on to question 2. They're going to get a little bit harder than this. So here we've got another isosceles triangle, and this angle B here is a reflex angle. We're going to be using the rule that angles at a point add up to 360 degrees. So first of all here, I'm going to give this missing angle a label. I'm going to call that C. And C, angle C, is equal to the leftover bit, right? 180 degrees, take away 2 lots of 65. It's 2 lots of 65 because we've got another isosceles triangle. So I have to write that reason down. So angles in a triangle equal 180, and base angles in an isos triangle are equal. So C works out to be 50 degrees, and that means that I know angle B is equal to 310 degrees. And the reason for that is that angles at a point add up to 360 degrees. I'm going to show you the minimum amount of working that we'd like you to demonstrate here. So you can write this one on if you want. You don't have to write that it's reflex, but you do have to write these reasons, because the wonderful thing about geometry is building up from some very simple reasons to finding lots and lots of different parts of a problem. So we want you to give your reasoning starting from year 9. You don't have to write this line down here. Okay, so you can say, I think it's fine to say that C is 50, and then to say that B is equal to 310, because the angles at a point are equal to 360. On to question 3. So this is actually a unistructural one. This is just an example of angles on a line. So we can say that C is equal to 180 degrees, take away 85 degrees. You don't have to show my adding up for those, it's fine. And that gives me 95 degrees. And my reason is that angles on a line add up to 180 degrees. On to question 4. So this is a little bit more interesting. I've got an equilateral triangle. I know that because I've got these 3 marks here. And here I've got a square. And we have to find 2 angles in here. First we have to find angle D. Now that's a really easy one. We know that we've got 3 angles, and they have to each be the same. So D is equal to 60 degrees. The shorthand for that is equilateral triangle, angles equal 60 degrees. Or you could do it using the main one, that equilateral triangles have 3 equal angles, and they add to 180. Now angle E, so let's call this bit of the angle in here F, just that little bit. angle E is equal to 60 degrees plus 90 degrees. So that's 150 degrees. Now the reason for that is because angles in a square or angles in a rectangle are equal to 90 degrees each. Question 5. Okay, we've got some parallel lines here. The easiest way to get F is to use the rule about the exterior angle in a triangle. So first of all, what I'm going to do is forget about the parallel lines. Just look at this triangle here. We know that 100 degrees here must equal this angle plus this angle. So F is 30 degrees. So the reason for that, the shorthand, is exterior angles in a triangle are equal to the sum of the interior opposite angles. Now what about G? Is that easy or hard to find? Well, it's really easy, right? We've got parallel lines shown here. So G, this angle here, is in the same position as this angle here. That makes them corresponding angles around parallel lines. So G is equal to 70 degrees. Corresponding angles, parallel lines are equal. One last one. I'm going to do some harder videos later, but this is just an in the middle one to get us started off. Right, we have to find angle H. Now there are quite a lot of different ways to get into this problem, but I think the easiest one is to find this angle here. And we're going to give it a name. We're going to call that K. Right, so what's K? Well, we're just going to work with this big triangle here. Well, that's very messy. I'm sure Don Steward would not approve of that messy. I'll just clean that up. Right, here we go. So K is equal to 180. Take away these two added together, which is 120. So K works out to be 60 degrees. Now what could I do next? Well, I can do lots of different things here. I'll show you a couple of them. I can get this angle here. So we're going to call this angle here L. So the reason for this one is angles in a triangle equal 180. And then L is equal to 120, which is angles on a line equal 180, but I'm going to show you a shorter way soon. And then H up here is in the matching position to L. So H is also equal to 120 because we've got corresponding angles on parallel lines and they are equal. But let's look and see if we can see a smarter way to do this. There's a way with a little bit less work. So it doesn't matter if you do lots of reasons as long as one follows from the other. But in this one here, we've got this angle and we've got this angle. So we can go directly to this angle here, let's call it M, because M is equal to the sum of these two. So M is equal to 120 degrees, so that's 45 plus 75, because the exterior angle in a triangle is equal to the sum of the interior opposite angles. And now we can go straight to H because it's corresponding and the lines are parallel. So there you go. That's just 6 questions to get us started. This comes from a big PowerPoint that he did that ramps up to some really quite tricky problems. So over the next few days, I'm going to just keep on making videos that increase in difficulty. Thanks for watching. Make sure that in your book you've got some good diagrams and some really good working for when you come to revise this topic.